We're going to continue with the sine and cosine rules. We learned about the sine rule, and today we're adding the cosine rule to that. Just to make one thing obvious is we use the sine rule when we have triangles where we have two angles and two sides. We're working with two angles and their opposite two sides. And one of the four is unknown and we're trying to find the value of it. That's when we use the sine rule. We solved this problem last time. The cosine rule we use when we have three sides and one angle. And one of those four things is unknown and we're trying to find the value of it. So an example of a problem that we'll be able to solve is this, where we have three sides and one angle. In this case, the angle is unknown, but we're also going to look at a problem where there's three sides, one angle, one of the sides is actually the unknown, right? So cosine rule we use where we have three sides, one angle. The sine rule we use when we have two angles and they're two opposite sides. All right, let's look at what the cosine rule actually is and how we get there. I've written all of this down beforehand. I hope that's okay. Again, we have a triangle that it's not a right triangle. The triangle's called ABC. Because there is no right angles in there, I've drawn the height of the triangle again, like I did with the sine rule. It is perpendicular to the base, so it makes a right angle here. We've labeled this side H, and we've labeled this new point Y. It is like one of the three angles in this triangle, Y. Y is also one of the three angles in this triangle. And the size of angle Y is 90 degrees. Watch how angle C, its opposite side is called small letter c. Here we have angle A, the opposite side is small a. Here B, angle B, its opposite side is labeled B. Look, I redrew the base here to show that from this end to that end, we're going to call B. It's called B. That's what we always do. Because we need to look at the length of this side to define the cosine rule, we decide to call this X, which is why I redrew the base again down here and said, look, this perpendicular line cuts it right here. We're going to call this part of the base X. And then, of course, this part, the part that's left, is B, the whole base, minus X, this piece. So B minus X is the length of this. All right, so all of side B is made up of X and B minus X. Together, that's side B. Okay, we are actually using Pythagorean theorem to come up with the cosine rule. We are first going to look at triangle CYB, then later we'll look at triangle AYB, this triangle. We're going to make H the subject of our equations and then combine two equations again and come up with the cosine rule. All right, using Pythagorean theorem, we can use it, right? Because we have a right angle here. It's an actual right angle if we look at only this smaller triangle. Pythagorean theorem, we know this side squared plus this side squared equals this side squared, right? So h squared plus this side. What is this side? The size of this side is b minus x. So b minus x squared. And it is equal to a squared, this side squared. Now, because I want h to be the subject, actually I don't mind h squared being the subject. I'm going to subtract b minus x squared from both sides to get this, right? Goes over there, minus b minus x squared. I'm going to leave that. Then I'm going to look at the smaller triangle. Again, this side squared plus this side squared equals this side squared. That's Pythagorean theorem. So h squared plus this side squared, which is x squared, equals c squared. I'm going to make h squared the subject of my equation by subtracting x squared from both sides to give this. Now, if h squared is equal to this, and h squared is also equal to that, then this and that must also be equal. So I'm going to pull these together and say they are equal. A squared is equal to this. There you go. Now I'm going to have to move things around so that I get a squared as the subject of my equation. I'm just picking one of the sides to become kind of the subject of my equation, right? I add b minus x squared to both sides so that it disappears from this side, right? And it is added here. Then I'm going to expand the brackets. So this stays the same, as you can see, plus b squared minus 2 times b times x plus negative x times negative x is x squared, right? Now I notice that I have a negative x squared and I have a positive x squared. They add up to 0. So all I have left is this, and I rewrote that up here. Then I actually like to have b in front of c, just because the alphabet also does. So I'm going to switch the order of these two, which is fine, right? I'm just adding terms. So a squared equals b squared plus c squared minus 2bx. I have an x in here, which is not, we just put in the x to be able to say something about h. X is not, it's part of one side, right? And I said we're going to use this cosine rule to work with situations where we have 3 sides and 1 angle, and one of them is unknown. We're not working with parts of sides. We want an equation with only the entire side, so A, B, and C, and 1 angle. So we need to find a way to get rid of this x. This x. So we need to look at our triangle again in order to to be able to say something about x and then hopefully get rid of it, which is gonna work because I know I looked in the book. So this piece I rewrote up here. And then I said, well, let's look at this triangle again. This is the triangle that has x as its side, right? The cosine of angle A, remember cosine is the adjacent side divided by the hypotenuse. Adjacent over hypotenuse. So the cosine of A is the adjacent side, x, divided by the hypotenuse, c. If I want to make x the subject of my equation, I multiply both sides by c, right? And get x equals c times the cosine of A. Now, I wrote this up here. That was what we came up with down here, right? And I'm going to replace x, because I don't really want it there. I'm going to replace that with this expression. Apparently side x is equal to side c times the cosine of angle A, right? So I just plug this in for x. And I get a squared equals b squared plus c squared minus 2 times b times c times cosine of a. C times cosine of a. Put that in there, right? Now that is a useful equation that uses one angle, A, and 3 ABC sides, right? I can rearrange these terms if I want cosine of A by itself to make that the subject of the equation. You can pause the video and try to prove to yourself that you can go from this equation to this equation, but you can. So these are actually two different ways of stating the cosine rule. This is the cosine rule, written two different ways, right? Okay. And just like with the sine rule, one of these two forms of the cosine rule is easier to use when finding an angle, and the other one is easier to use when finding a side. Look at my first example. I have 3 sides and 1 angle, right? Cosine rule situation. We have a missing, we have an unknown side. That's what we're trying to find. When we're trying to find a side, we want the side to be the subject of our equation, right? If we were trying to find an angle, we would use this form of the cosine rule. These are the two forms of the cosine rule rewritten on this page. Here we're trying to find a side, so we use this form of the equation. So using the cosine rule, we're going to call this side A. We're going to call this side B, and someone is ringing my doorbell. We're going to plug in these numbers.
Mama.
Yes.
Start.
And find this length. I will be back later.